Hello, my name is Christopher Moore. I'm going to be presenting to you our final embedded project. Dustin Woodman and I developed a radio direction finder that can home to signals at 915 megahertz as long as they're transmitting Manchester code or phase encoded data. We accomplished this task by first designing a 3D enclosure. The 3D enclosure consists of a dish-like antenna that has aluminum foil wrapped around the edges. And in the middle of this dish, we have the MSP430, which is a launch pad, a development board to learn embedded systems. And on top of the MSP, you have the radio board that transmits our Manchester code. The aluminum foil can or cannot be attached to the directional antenna that transmits this to increase range respectively. For this practical exercise, we have one MSP430 hooked up with a radio header board that's transmitting Manchester code. If we want to detect this Manchester code, simply pick up the device and point it at the board. The left LED signifies how long since we've received a valid transmission. The red LED, if it's on, means we've received 0 errors, and if it gets turned off, it means we've received an error. The green LED is governed by pulse width modulation. We take a measurement of time from each valid transmission that we receive. From that DT, we set the pulse width modulation, or the percentage of duty cycle that the LED is on for. Simple as that.
Hello, I'm Dustin Woodman, and I'm here to talk to you about Hamming codes. Hamming codes are what we use to determine whether or not to turn on the red LED. In our case, this is a measure of the quality of data that is actually received. Now, this doesn't help us with transmission errors of other sorts, but by adding parity data, which we can get by XORing our data bits, we are able to detect and, if we had wanted to, correct errors. Now, by adding these parity bits to our data before transmission, we'll be able to detect them by using the same algorithm we used to add this to our transmission. So let's say we have received a transmission and we want to know if the data is good or not. We will recalculate the parity data, which we got by XORing data bits together, and this is going to give us something they call a syndrome. Now, it can tell you which data bits are bad if you're trying to correct errors, but really, if you're only wanting to detect errors, all you need to do is check if it's 0 or not. Additionally, we can check another parity bit, which is calculated over all of the data bits and parity bits. If either of these are bad, the packet is bad.
For this experiment, we have connected the antenna to the aluminum foil on the outside rim, and we're going to try to see how far we can detect a signal from. Please pay attention to the LEDs.
And we're off. And we're back on.
Good?
I had it there for a second. I've lost it. Ooh, there it is. Wait, I lost it. There it is again. There we go.
What's going on, man? We've decided to do the ultimate test. We've hidden the transmitter in a bush. And we're going to try to locate which bush and where it's at. I have no idea where it's at. My companion Dustin has hidden it in one of the bushes that are to your left and your right here, and I have absolutely no idea where it is at. So nothing but my handy dandy directional finder is going to help me find my target. Got some reading right here. It went away. I don't know if it's in that direction. Whoa! I just got something, but definitely have something in this direction. Can be in any of these bushes. These bushes are acting like an antenna in themselves. So it's going to be really hard to. Well, all right. So I'm gonna cancel out the waves on this side. Use my body to cancel out signals behind me. So I know it's not these three bushes. Could be this bush. All right. So the way that we have it currently configured, I don't know which bush. It's definitely one of these three bushes, but I can't tell which one it is. So what I'm going to do is I'm going to go ahead and disconnect our little additional range that we have to kind of get more resolution and give up some range. So now it's hardly going to pick up any signals at all, unless I know for a fact that it's MPE. So this is just a way for us to increase accuracy here. A very simple method. Here we go. Just decrease my resolution, and I just narrowed it down to one bush. Just found my target. Mission success. I'm going to turn it on.